All right. Let's get ready to rumble. Welcome to our Smackdown on Digital Twin with Rob Thunderstruck Tiffany and Aaron the Blade Osbrook. We're going to talk all things Digital Twin, and please enter all your questions in the chat. And with that, we're going to turn off this really heavy echo. And let's get serious now. Okay.
Serious?
What? Wait a minute.
Really serious. I've got my between round bell here. So we're gonna start with maybe just quick intros. Aaron, why don't you go ahead and introduce what you guys are doing, what Clearblade does.
Yeah, you bet. So Clearblade, we're a software company. We've been in the IoT business for almost 10 years now. Ultimately connecting the things. And then really these days we're providing not only the core platform for edge and cloud side, but also the application. We call ours intelligent assets like others in the industry, but it is really about how do we begin connecting this stuff up from our operator view, from our perspective in the field.
All right, cool. Mr. Tiffany.
Yeah, so I'm head of IoT strategy at a little company called Ericsson. So we're a Swedish company and we make networking telecom gear. Maybe you've heard of 5G. So we're one of the little handful of companies that actually makes that stuff. And so spreading that far and wide all over the world, the IoT stuff we're doing is probably more narrowly focused than what Clearblade does. We're mostly focused on the connection part, the connectivity part. We have a global connection management system that spans, I don't know, like 36 mobile operators to get you connected cars, connected whatever, anywhere in the world if you're doing cellular IoT. So that's what we're all about.
Cool.
And then I am also working on a rogue project applying IoT and Industry 4.0 principles to agriculture.
Yes, you're
Cool. Very cool.
I also heard that you invented the internet with Al Gore. I've heard you relay that from time to time.
Yeah, when they finally let us out of DARPA after we invented all that stuff and we gave it to the world. You're welcome, everyone. And then shortly after that, created the Internet of Things. So it all in a day's work, you know.
Is he in this session? He's probably listening right now to see how what you've done with it, I would imagine.
Make sure he's keeping it real. All right, so we're doing round one. Round one.
Round one.
Oh, my signs don't show. Anyway, Matt.
Yeah. Oh, there it is.
Round one.
Okay, round one. What is a digital twin? Let's start, because I know we all probably have differing opinions, and that's one of the challenges in the market. Everyone's kind of thinking about it differently. So maybe, Aaron, let's start with you. What is a digital twin, or what do you think it is?
Well, if you were putting up with me the past 2 weeks, what I really tried to do this time is not just have Aaron's opinion about digital twin, but I tried to pretend I was learning it, right, from the kind of the initial what's in the market. I specifically have looked for definitions. Specifically, I like these two over other ones. One comes from Deloitte, one comes from the IoT community. There's lots out there, from an exact replica to things that are very difficult to achieve, while others are more tolerable. I like this top one, in a digital profile with historical and current behavior of a physical object or process that ultimately does some good, right? Optimizes something. It's pretty relevant. It certainly makes what we do with intelligent assets and inclusive to that. But it's also, from my perspective, far too broad for someone in the field, someone trying to optimize their factory or optimize their field workers and such that are out there that are doing things to actually be strategic with. So I believe that, we have to get beyond this definition. Even the second one goes beyond just the optimization of processes, but gets into simulations as well, and twinning services. But ultimately, This is where we struggle. This is why I don't like the term digital twin. Is it's so big and so broad that so much can be a part of it all. And as someone coming at it from an operations side, how do I address the real challenges I have? It's difficult to take this definition and turn it into something actionable for me and my machine, my equipment, my workers.
Yeah, it certainly sounds fancy.
There's a lot of smart people in this space, right? I mean, you go and you Google this, what is it? And you're going to get a lot of answers, right? And I think that's part of the challenge that we all see here.
Yeah. Yeah. Rob, what about you? What do you think, see as a digital twin, or kind of where are the boundaries?
Yeah. Well, instead of looking at quotes from a bunch of Johnny come lately consulting firms who just heard about digital twins from a leaflet they read last week, since I created digital twins shortly after back when the dinosaurs roamed the earth, shortly after we created the Internet of Things, luckily you get to hear it from the source. Okay.
Perfect.
So this is like kind of when Neo in the second Matrix movie got to meet the architect. It's kind of that moment for you, actually. So that's what this is. So yeah, we are trying to model, at the simplest form, you were trying to model digitally. The reason we call it a digital twin is there's the physical thing. It's a car. It's a machine that makes other machines. It's a plane. It's a jet engine. It's got a lot of attributes, properties, things about it, right? And then there's the digital version of that same thing. IoT has been trying to do this for a long time anyway. They've just done it a lot of different ways. Typically, it's been data, it's been rows and columns and databases and things like that. So back when I was at Hitachi and we were building Lumada, which is an industrial IoT platform. So back in 2016, we decided the core of the whole system was going to be based on something we called asset avatars, which is what a digital twin is. It's what an intelligent asset is. When you're in manufacturing, like Hitachi is, you refer to everything as an asset. And so that made sense to us. The avatar thing, aside from sounding really cool, like a 8-9 foot alien thing, it also resonated well with all our colleagues in Japan. And actually a lot of the folks in Asia think avatar is actually a better term for what we're trying to communicate with this digital mirror of the real thing. And so, yeah, it's just a simple process. And you know what? We found people had a better, easier time of wrapping their head around what it was when we built these. Instead of it just being thousands of rows and columns of just meaningless data, we said, no, we're going to shape this out of clay and make this thing, digitally that looks like the car, and something that an average person, when you're building an IoT system, that first baby step before you do analytics or anything, you basically have an asset management system before anything magic happens, right? And so doing this avatar thing was a great way to represent those assets for us. And so we just kind of went all in on that. And then over time, you can expand it, to processes, groups. We kind of went down a path of this, thinking of it like a Russian doll, right? There's machines that could be assets, avatars, digital twins, but they have subsystems that maybe should have their own twin. And maybe there's properties of the subsystem mapped to things of the overall system, like an industrial robot on an assembly line. And so what are the causal relationships between subsystems to the overall deal, or to some aspect of your engine failing in your car to the overall car? And I think we just kind of progressed from there. We started thinking, well, why just call an assembly line a group? It is a group. It's a group of industrial robots and conveyor belts and stuff like that. What if you made that whole thing a twin unto itself, where properties of the constituent twins of the machines, the industrial robots, map to properties of the whole group, as it were? And we kind of went from there. And so again, it was kind of more of an industrial view of things. And we did that all the way out to model factories and things like that, and inputs and outputs and stuff like that. So that's kind of where we came from. But yeah, lots of fun.
Yeah, I mean, it's really a system of systems approach, in the end. And I mean, I've had people say, "Oh, it's a digital twin. It's a CAD model." Yep.
Yeah,
right?
I've heard that. Yep.
Digital twin is a dashboard. No, and just all kinds of different variations. But I guess what I'm hearing from you guys is probably like one of the best. I forget where I picked it up. Is like the definition is it's it's a tool to compare as designed, as built, and as operating. And that's where you've got the original design um, that you intended to build. Then there's the manufacturing process and the result of what you build. There's going to be deviations, and then there's sensing that checks the as operating. And if you mash all that up in this sort of in a digital twin, it gives you kind of a full picture of the life cycle, and you can kind of learn from it. So that's kind of one way that I've thought about it. But I think you were saying similar things and nuances. But yeah, Aaron, go ahead.
Yeah, I mean, one of the things that you guys have both done is you've immediately taken it industrial, right? And I think that is the intent of what the spirit of the digital twin is, right? I mean, we go back, and I mean, I think last time we talked about it, right? The Apollo moon landing, right? They had a physical twin that sat in their office or wherever they sat at, and they had a sort of a digital twin with the one computer they owned back then. And even then, right, early in this, we were seeing those jet engines like you talked about, right? Those twins, that makes a lot of sense, right? I think the challenge we have is if you go back to those original definitions, things get super broad, right? And especially as this term has gotten popular, I could argue based upon this that Salesforce models the sales customer relationship, and it's a digital profile. So now we're going to have Salesforce selling digital twins, right? And not to pick on one, but there was a huge announcement last week about a digital twin of a supply chain, right? And I can see how we can get to a factory, but a supply chain, when most folks haven't figured out how to backhaul data off a boat, is extremely ambitious and putting expectations somewhere far beyond what I think the spirit of what we're saying is it is an asset. We want to do more with it. We want to know more about it. We want to make some decisions about it. And I love that we've already started with, this is about industrial processes more than it's about to the joke there, or to the statement there of the earth, right? So I'm trying to put it all together.
Yeah, that's a good point. When you think of the spirit of it, so, it's great seeing the limb there, the module. It takes me back to being at Mission Control in Houston with Gary Sinise. And we are just working with that physical twin. Well, Tom Hanks and his buddies are up there, how are we going to get this square peg into a round hole? And so, we all have to remember to give lots of love to Gary Sinise around the founding of the digital twin concept. But you're right, people are going rogue, people are going nuts. They're saying everything's a digital twin. And you know how it happens when everything is something means nothing is it. Absolutely.
Yeah,
So,
I mean, are we all saying that it has to have some tie to the physical world and even take a further sensing in the physical world? Like there's an inherent tie to IoT?
well, like you mentioned, a lot of people think of digital twins with PLM, don't they? If you think of our good friend Rick Bellotta, who created ThingWorx and then sold that to PTC, PTC was all about PLM, and digital twins was one of the core capabilities of ThingWorx back then. And as you said, as designed at runtime, and a lot of people when they think of digital twins, real quickly, they probably are thinking them at runtime, while they're being used, and that's where they think of IoT, because the twin it's a data structure. First and foremost, I got to structure what that asset, that thing is, whatever it is. It's got 4 tires, it's got an engine, it's got whatever. And then there's real data flowing in, telling us the current state of that object, right? And then you attach KPIs and analytics and trigger events and things like that based on it. And so that's easy to understand.
Yeah, I mean, one of the things, it's interesting that I think it makes it far more valuable if we do say sensing is part of it, right? I mean, we're doing a project right now with a water network, and basically watching pressures and flows, predicting leaks, understanding types of pipes. I'm actually reading this past week about, this is exactly a digital twin, right? I haven't called it that yet, but what a great opportunity, right? We understand what's going on in that network. But I guess the question I have for you guys is a digital twin, if we're going to optimize a process, do we have to enrich it with some additional knowledge, some additional understanding beyond just the sensors, right? Because, we can connect up and know telemetry, but if we don't know what that telemetry means in terms of the business, have we made a digital twin either in our, or an intelligent asset, right? That's the question where I think you have to go secondarily, Jason, there is you have to be able to understand that data and even derive something from it.
That's a good point. We used to, so when building Lumada, we also had this other product we munged together. It's called Pentaho. It's another part of our company. And it had a bunch of ETL connectors, except transformer load connectors, about 100 to lots of different data sources. And so to Aaron's point, it was critical to do data blending and to pull data into this twin from different sources. Because you're right, and we see this in IoT all the time. All they ended up doing is creating yet another data silo. All they have is machine data, and they lack context that they would get if they had other data sources being blended in and fed into those twins to derive better insights. Because you're right, you're only seeing part of the picture if you're just getting sensor data and not, how do you know what it means? You know, from the simplest thing, oh, it's device number 25. What the hell is that? You know, and so there's other things. You know, companies have business systems. They have KPIs around certain things. They have SLAs. They've got all kinds of stuff, and you need to suck data in from their company's different business systems to kind of mold together a better view of what's going on, for sure.
Do you guys, so there's a question actually from Vishnu on, in the future, will digital twins rely more on real world data or synthetic data? You know, it's kind of along the lines of what we're talking about, you know, synthesized data from model. Thoughts on that?
Well, you know, when you talked about simulation, and this may not be what this person's asking about specifically, but when you use a digital twin, so like if you've built a platform that's a runtime for digital twins, and so that's a data structure, and then you have data feeding in live data, and then you have software agents, bots, whatever, what do? They look at the incoming data, they find out, oh, this data belongs to this asset, and it's going to go into this structure. And then maybe I've got KPIs attached to every property of that structure that tells me, well, what does it mean when I do pattern matching with the actual data and the properties of that twin, right? And when I do, so when you talk about synthetic, we do synthetic stuff all the time to simulate. So you put fake data. It's the whole wind tunnel thing, right? I slam fake data into my system that I built to see how does that asset behave. And then you can stress it, put it under all kinds of crazy conditions. At least that's kind of where my head's at with synthetic data.
Yeah, I mean, synthetic's tricky, right? Because now if it's all synthetic, then Meta or Minecraft or Roblox or whatever, right now, that they're going to be way better at that, right? That's what they've made, right? I guess I look at it, and I could turn the word synthetic. We use that word to mean we're taking camera feeds and we're deriving it. So it's not the raw sensor, right? We're taking audio feeds to derive the fact that there's humans around. So it's synthetically taking another kind of raw sensor and deriving attributes versus just on off buttons that are temperature readings. So in that sense, synthetic data will absolutely be part of it, because it'll come from these other types of kind of raw sensors, video and audio, and spectrums and such. But in general, if it goes into all synthetic data that's purely generated, I feel like we've lost the spirit again, other than maybe, you know, validating some product kind of capability.
Yeah, that's a good point. You know, I've probably wrongly over the years, when I would talk about twins, I'd always try to make it something people understand, like a car or whatever, and it's a machine. And I realized that was taking the easy way out, because machines are intelligent. Cars are super intelligent. If you sit in a car and you look at the dashboard, there's a million lights that reflect all kinds of sensors that are in your car. And you go, wow, what's IoT? Well, I'm just remotely sending that stuff somewhere else, right? But it turns out that's taking the easy way out, but it was a good starting place. You know, I spent the whole summer on farms, trying to apply a lot of these things that we were used to doing in the industrial world to agriculture. And guess what? It turns out those plants can't really talk to you like the car can.
You can talk
and so I know. I whisper to them. Yes. Yeah. But what are you doing? It is kind of synthetic. It's the twin might be an apple tree, but the data I have it's inferred from other things around it, right? And so I'm getting soil data, I'm getting data about the air, the atmosphere, all kinds of things. And then I'm applying, I've got sensors that are going to give me data. And then I've got a twin that's kind of saying, well, the twin's the tree and this is what we care about. And so I got to mishmash that together and try to infer the health, the vigor of the tree based on a bunch of data that's not about the tree. The tree is the twin. And it I don't want to say I had an epiphany, but I was just like, oh, this tree is not a car.
Yeah, no, I mean, there's a ton of things in agriculture, right? I mean, cameras are going to be huge for yields and those sorts of things. And, the fertilizer or the sulfuric acid that got sprayed below the almonds, whatever that is, right? All of that data matters so much in terms of getting that ultimate optimization out of that plant.
Yeah. And that was a really terrible, I remember reading that horrible news story about you, Aaron, when you flew that crop duster and were spraying all the crops in California with sulfuric
Yes.
acid, and you just killed everything.
Hey,
That was a
man.
real shame.
Yeah.
A lot of people died because of that, but don't worry, we won't let anybody know it was you.
It wasn't me. It wasn't
All
me.
right.
So Michael here had highlighted a digital twin example he saw with augmented reality. So kind of playing off the physical digital, like AR seems to be a fit into how you flip things back on itself. And you guys seen applications around AR and what you would consider digital twins?
I saw Aaron this last couple of weeks doing some kind of AR thing, so he must have the story.
I worked really hard to turn off the television. I walked through my whole world to get that button pulled.
Was that episode 6 or 5?
I don't know. I lost track.
Yeah, in case you guys watching missed it, Aaron did a whole series. I think you ended on 10.
I did get my degree did arrive, so yes.
Good. Yeah.
Excellent.
Yeah. So I personally think that this notion of, we've created synthetic data that simulates what we think it's going to perform like, and then you build it and then you put it into real world and then you sense how it performs. You correlate that back to how you synthetically designed it, or the data that you use there. And then in interacting with that, you can use tools like AR. You mentioned, sensor, cameras and whatnot. So it's really this broader system.
Yeah. I see a lot of people just jump and say, oh, digital twins means VR goggles on. That's what it is. I hear people say that all the time, or they say AR. And you have to remind, it's like what you're viewing is just a view of the source data. The twin is the structure and the data, the current latest state of the data and all the historical data, right? It's not AR, VR. That's just one output of that kind of stuff. And then just like on the flip side, when you were talking about CAD models, I remember first time I ever saw Boeing using CATIA from Dassault Systems to design aircraft, and a lot of people think, well, that's a digital twin. Now, I think we all talk about digital transformation, which I think we have to take a shot now. But the idea that I'm going to start creating physical things digitally, and I'm going to monitor them physical digitally, and I'm going to the whole life cycle of that thing. And so, instead of shaping a car out of clay, I'm going to use something like CATIA or other systems like that to digitally create it. And then what's cool about digital twins is when I love to talk about the Tesla, because guess what, normally with a car, you get an owner's manual. And I say, that is your physical version of that digital twin. That's the closest thing we got. When you think about what an owner's manual, it tells you all the attributes of that car and when you have to change the oil and repair and all these things, which is kind of the things we think about when we're trying to take care of these assets, right? The Tesla, they deliver a digital twin because it's a computer on wheels. And I think that's a goal when we think about all the stuff that folks are working on, this whole Industry 4.0 stuff. That's where people are trying to get to, I think. It's going to take a while, for sure. But, because then when you have the twin of the whatever product, you make some hardware piece of product, we always talk about with IoT, your product, instead of depreciating over time, it could get better over time, right?
Good
Because
learn.
you update the software and you make it better. Just like when you hear about a Tesla, go, wow, my Tesla is doing more stuff this week than it did when I bought it last year. Anyway, I'm just rambling.
Well, I mean, the augmented reality. Oh,
All right. We got a nice first round. We'll come back. I want to, in round two, let's chat some of the challenges. We were touching on some of that, and I think touching on AR, on kind of trends would be good. But so digital twin, a lot of different questions. I think we're hovering around similar stuff, but what do you see as the major challenges? I know, Aaron, when you talk about it, it's like, let's do, start small and do the basics, up front. But what do you see as some of the key challenges to enable this vision of digital twins?
So when I look at it, and when you see what's happening, you've got a lot of folks that have, quite frankly, they have digital twin strategies from the top, right? We are going to do that digital transformation. Twins are our strategy. And when you look at it from where are we going to do actually at the bottom, there's very little to help to tie those two worlds together. So, when I look at the problem, it's getting the data. It's getting the data and it's figuring out how to understand it, because it doesn't come back pretty most of the time. And even after you understand it, then you got to get it over 5G, right? And understand how are we going to get it across 5G and then secure it. And then you got to get it in the cloud and decide how are you going to take it all from all these different places and put it together. And if you think about all those challenges, right, there's infrastructure to buy, there's selections of hardware, there's sensors, there's protocols, there's networking, there's a cellular bill or a satellite bill. You've done all of that, and we still haven't hit on what we said was key for digital twin, which was to begin to understand that data, derive some information about it, and potentially improve a process. So I totally, despite the fact that, again, it goes back to the 1960s with the Apollo in terms of the first kind of one we've understood, you have understanding how to get started at the ground off of the machine data. Even if you've got 7 connected products, bringing in to understand it in the terms of your factory, that is the challenge, right? And getting the right application down there and putting these pieces together. I think actually the three of us represent like completely different parts of how you solve that problem. And all three of us need someone like each other to deliver and to begin even just studying that connectivity or getting that data out. So when I look at it, I see this is a data challenge. It's a connectivity challenge. First and foremost, that's how you get started with digital twins. And it's a bottom up. As much as we want it to be big, grand vision, it is a bottom up attack.
Yeah, I'll tell you. So I've been doing this for a while, like IoT first, and then of course Edge. But past 8 years, shortly after Rob invented IoT, I have seen so many diagrams, these huge like high level architecture diagrams of like hubs and data lakes and blah blah blah, and this tiny box on the bottom that says sensors and gateways, which basically tells me you have never actually done. Because that is the hardest part.
Yeah, the number of times I've seen the Netflix architecture copied to be used in an IoT solution blows my mind, right? I mean, it's like, all it is about, it's data lakes and stores and message brokers and IoT services, right? And I'm like, well,
yeah.
You know what?
Rob, go ahead.
I think it's important to bring all that stuff back to earth. I just want to say, all those architecture diagrams, all these designs, the way people come up to me all the time and tell me authoritatively, well, you've got to do this kind of Netflix microservice architecture, and you've got to have this message bus, and it has to be in this cloud, and you've got to do this, or you can't do IoT, or you can't do this. I just want to say right now to the rest of the world who's all watching right now, they're totally full of it, because this stuff is, people overthink stuff. We got too many architects who are trying to see how smart they can be to their friends. This stuff isn't as hard and complex as you think it is. If I was able to real-time data when we were monitoring vending machines in the 90s, we didn't have all that stuff. I'm telling you right now, when we built that stuff, that technology in the 90s, we raised about 60 million in funding, and we were monitoring vending machines all over the United States. We didn't have a cloud. We had the most primitive data networks, cellular, early days. There was actually, like the beginning of any mega trend, like wireless or computers or whatever, there's always lots of people trying to vie for how that's going to play out. We used any and everything. We created our own little tiny data packets. What was our database? It was Access. What was the GUI running? It was on Windows 3.1 Visual Basic. And yet, magically, we were somehow, and we built our own black boxes and firmware and had them in vending machines. We created our own data networks and antennas. We created our own wireless modems. I've seen how hard it can be where you have to build everything from scratch in the early days. And so when I come to today and people tell me, oh, well, you can't do that unless you do this, this, this. I don't have my referee outfit on like you do, Jason, but I throw the BS flag on that because you'd be amazed at what you can do. It's just things sending data. In fact, if I think about sheer scale and data volumes and things like that, I hate to break it to everyone in the IoT world. We're not even remotely coming close to experiences I've had working in financial services and building trading exchanges. Nothing in IoT has even come close to what the stock market, what NASDAQ or the New York Stock Exchange experiences in one day. It's not even close. And what do you think those things run on? They still run on relational databases. And people go, well, you can't do it if you're not using some NoSQL database sharded out 1,000 times. So I'm like, well, how is it that Wall Street does it? And they're kicking your butt. So anyway, don't overthink things, folks. You're just moving data from a bunch of little things to some place, and you scale appropriately. Don't get people telling you got to buy all this magic stuff or it won't work.
Yeah, I mean, I think part of the problem is that as the hype picks up, then there's so many different tools and that just confuses people. But I'll also say that the number one and number two challenges, say with IoT, and I would say with any of these technologies, is it's nothing to do with technology. It's business case. Is there a reason to do it? And two, it's people. People are complicated.
They are.
When you're instrumenting the physical world, then it uncovers a lot of people get kind of freaky about stuff. You might uncover inefficiencies or different types of behavior. So you really have to think about it when you get into it.
I'm so glad you said people, because I've experienced people trying to sabotage IoT technologies that I've been involved in because it made things too efficient for them. And they started, this is like technology in general 101 though, right? And automation. There's this notion of, is this technology going to replace my job? That kind of thing. And so back in the 90s, doing the vending machine things to make routes more optimal and all that kind of stuff, we had vending route drivers sabotaging our equipment and our machines because they were seeing a vision of the future that they didn't like. And so to your point, Jason, people are a big part of this stuff. They need to know that this technology is here to help them to augment what they're doing and not replace them.
Yeah, I mean, you mentioned it, right? So the vending machine, right? For you guys to take that time to pick that hardware and to pay the cellular bill you paid, right? You had to find a process. You had to find something to save, right? You had to save on, number of Cokes not sold because it got empty, or sorry, I don't mean to brand name Pepsi's, whatever you drink, right? So ultimately, you have to find a process. And there's questions about the architecture and that kind of stuff. In the end, a lot of times it comes down to you pick the architecture that matches the process, because if you're trying to do 75,000 edge gateway units, to process a bunch of remote locations, that's a big price point. And suddenly performance matters a lot on that software, that you can go out there and use a very low end gateway or whatever it is. So it is really interesting when you think about the attributes of the software that we're putting together and such, and it all has to match the use case and align. So it is interesting that IoT is a lot about finding the process, finding truck rolls, safety, accidents, new customers, growing customers, finding something in a process that justifies why we're all doing it along the way.
Yep. So last I checked, systems are made of components from different suppliers, typically, systems of systems, yeah. So one of the questions is any bets on upcoming standards? I know, there's Digital Twin Consortium, there's other efforts. A lot of people are creating platforms, and standards are always a tricky subject. But thoughts on standards? Do we have to get to a standard? Will we ever get to a standard? What are your thoughts on that front? I have my own, of course.
Yes. Don't you love that cliche? We're just going to build that one standard, to replace the 100 other standards. And then what will you have? We now have 101 standards.
Mhm.
It became clear to me early on, especially just time at Microsoft building Azure IoT way back when the realization was people kept saying there's no standards, we can't do IoT and all this stuff until we have a standard. And I'm like, well, then you're going to miss the whole boat if you wait for the standard, because it's not showing up. Turns out there's hundreds of standards, and to be successful, you have to play ball with all of them, or a lot of them. There's different data formats, wire protocols, structures, all kinds of stuff. And the folks who are successful just have to work with a lot of them, especially, in the industrial world, man. All these, there's hundreds of bizarre wire protocols that people have never heard of, right? To talk to machines. Everybody's like, I thought this was the Internet of Things. I thought it was all TCP IP and stuff like that. And I'm like, nope, maybe part of it. It's messy.
Yeah, I mean, I think so early on in Clearblade, when we were doing this, right, this was the last time I learned not to preach standards, right? I preached MQTT. We invested heavily in an MQTT ground up broker, and we loved it. And we're very proud of it. And it's still in our product today. But in the end, it's just one piece of a solution, right? OPC UA is going to be in the ecosystem. Modbus is going to be in the ecosystem. Clearblade has to talk all of these. That's how we bring all this data in, right? And we have to recognize that, yes, Apple or somebody big is going to make a new wireless protocol, or 5G is going to embed NB-IoT, and we're going to have to do that, and LoRa, right? And whatever else along the way. So I really, really believe that if you're going to be successful in picking a digital twin and transformation strategy, you've got to look at having a strategy that will talk all protocols and really rapidly talk new protocols. So knowing how to kind of commonize that data each time it comes through from wherever it comes. I mean, that's just the reality of this, and it should be, because I was working on a project the other day with a group that's trying to set standards for monitoring these pieces of equipment that roll all around the country. And they were sitting there and they were saying, well, can we pick one wireless protocol for pulling off all of the possible sensors? No, right? I mean, some of these have different battery profiles. They have all sorts of different reasons. Well, could we pick a standard profile for how we send the data? If you don't have a lot of battery, you don't want to have an open MQTT connection. You want to post the data on your own terms, right? Different protocol. So, and then, we've got protocols that aren't even TCP IP that are all part of this, right? Profinet or Profibus, whatever we call that, right? That's a whole nother, all the way down the stack. And it all has to be part of this, because otherwise we're going to throw away a ton of how we do business today, a ton of how we build our products, and a ton of how we know what's going on.
Yeah, that makes sense. I mean, you basically have to broker between different standards, trying to pick one. Well, the moment you pick one standard, you're wrong to everybody.
No, I'm glad Aaron talks about the battery powered devices. I was using these devices that we created out on these farms, and yes, there's this hope that maybe the skills that all these mobile developers have, they'll be able to apply to having IoT devices talk to some platform or through an edge gateway and things like that. But the reality is, as Aaron said, there's battery life is key. If you're not indoors, if you don't have access to electricity, it's a different game. And even if you're totally in control of what goes on this thing, let's say I don't have to play ball with Modbus or anything else, I still have to think about the power budget of a device, and how long is this thing going to last? How many months is it going to last on battery? I know a lot of people say, oh, well, if you use LoRa or NB-IoT, it's going to last for 10 years. Still haven't seen that yet. And
Check
so
in once a week, then you can get 10 years.
there you go. and so it's things, and so it's math, it's a lot of your computer science things that you've learned. And so it's like, oh, well, maybe I need to think about that data format. Maybe I can't use XML and SOAP. Maybe I can't even use JSON. Maybe gzip's not even enough for me. Maybe I need to use protobuf or use some of these other formats to serialize data. Because what are you doing on a device, right? You're pulling data from the various sensors that are either built into the device or external, and you pull that together and you need to serialize it to send it over the wire, right? And there's a lot of ways to skin that cat. And so the protocol you're sending it over, is the wire protocol efficient? Are you using REST? Or are you using MQTT? Or are you using CoAP, lightweight M2M, all kinds of stuff like that? UDP versus TCP. There's overhead or a lack of overhead. Obviously, when we apply TLS security over this connection, that adds overhead to the payload, right? And so these are all things you have to think about, because your battery is taking a hit by the decisions you make when you're doing these devices. Or also, every time I want to, let's say I have some kind of interval I've set, let's say, oh, I want to report on my device or get sample data once an hour or once every 10 minutes or whatever it is. Does it mean I need to send data every 10 minutes? Or does it mean I sample data and log it locally? And maybe I have a scenario where I just transmit it once a day or whatever. There's so many decisions to make and so many choices that people who are getting into this space will find themselves making based on a power budget. Because let me tell you, folks, when you have stuff that's on battery power out in the field, whatever that may be, every time you have to roll a truck, get your pickup truck to go out there to replace the battery, you are killing your return on investment.
Oh, yeah. Every
single time. Like the whole purpose, all the value you're going to get from that one thing starts to fizzle away every time you got to go change the battery. Totally unrelated to digital twins, but I just wanted to say that.
Well, but I mean, it comes to standards. I always say there's a reason why we have Wi-Fi, cell, BLE, and RFID in our phones. They all do different things. They all have different power budgets, different benefits and whatnot. But the other thing I'll say is that anytime someone says JSON instead of JSON, I'm like, what?
What? Huh?
You're a data transmit standard. I like you over XML big time.
Exactly.
Well, but so one other thing though, and then there's other questions I want to get to, like as we talk about advanced class, but it's not just the protocol, the communication protocol, it's the data semantics, the data models. So I'm company X, I want to build a digital twin of my factory. And I think we can all agree, like, I've done a lot of work in the open source world around standards, and there'll never be one standard. You got to make them work together. But if I'm Acme Factory and I want my factory to be, I want a twin of my factory, do I have to do all of that work myself, or how do I segment that work and put it on my suppliers? Unless I dictate to everybody, thou shalt use this data model. Good luck. How does that work?
Yeah. So Intelligent Assets recognizes that most of our customers, nor Clearblade, is going to go tell some of these big folks how they have to give us data, right? I mean, maybe they have that kind of buying power. There's a few folks that might be the biggest oil and gas. They might be the biggest railroad, right? They might be the biggest building, whatever it is. But that's few and far between to drive how Microsoft and Google and ABB and these Hitachi are going to interchange data, right? There's no one person that can put that lever. So if you're a factory, I think you have to start with the idea that you're going to have your own understanding and you're going to bring it together. Right now, you may take a vendor's understanding, it's completely open, right? And well-defined. But I think you have to take the approach that you're going to be owning your own data model, and you're going to be taking your John Deere tractor and matching it with your Hitachi tractor and whatever, and bringing it all into one. I just don't see in the near term, right? And again, this stuff always comes together, right? We do have common understandings of things we figured out many, many years ago. But in the short term, and your smart factory initiative and your smart equipment initiative and your digital transformation, you're going to have to understand your own model and how you want to work with it. Because it's also going to be fed by your your enterprise asset management tool that you bought 20 years ago. It's going to be fed by your ERP tool that you home grew, right? It's these things, and it's going to use ServiceNow because that's what you just standardized on for doing work order flow, right? So that smart factory model, that data model is yours, and you should treat it as such.
Yeah,
And-
what he said.
Yeah.
I'm passionate about data models.
Yeah, well, no, because you're right. You might create your data model, like you'll model your twins of this machine you just purchased, but you're right. The likelihood that you're going to control the way they're sending data to you might get lucky, but you probably won't. And so it goes back to talk to any kind of protocol, data format. You're going to have to rationalize those into your standard inside your system, and then hydrate that instance of a digital twin the way you do it. And this is one of the challenges of IoT. You know, we talk about the complexity. There's just a lot of stuff that people didn't realize they were gonna have to do in order to make all this stuff work, because it's messy out there. You know, everybody's not singing from the same sheet of music. Everybody's got their own, right?
Yeah, and it's one thing to get the data flowing from a variety of standards. You get to a common model, output that to different systems. Now try to blend in the predicted performance through synthetic data, and then try to kind of overlay that with other sources. I mean, if you're doing it, I think in a sophisticated way, it's a massive integration project. I think
It is. This industrial IoT thing, we're going to be retrofitting old stuff for decades.
Yeah,
And people need to be on board with that, because they keep waiting for the magic to happen. When I was at Hitachi, we certainly realized we're going to have to start building all these giant machines that they make and embed, compute, storage, networking, power, software, the whole deal at time of manufacturing, so that at some point in the future, my grandchildren will be able to have seamless IoT projects and digital twins. But until that day, it's going to be a big mess for sure. No doubt about it. Like that.
Round 3.
That was a great idea, but it's
Yes. Not giving me a break here. So let's talk about relationship between digital twin. I mean, there's obviously a strong correlation, but just additional thoughts, and edge computing. How do you see the relationship, short of the obvious physical world component?
So we talked about, I jumped in on what I thought the big challenge was, right? Getting at these different data sources. Someone actually calls out, the Modbus and security and OPC UA and how these things work. You're not going to go into one spot and get at all this data and send all of those things across the internet, right? And so we're automatically going to be taking Modbus, which doesn't have the security we want, right, to be connected. At least I don't want that piece of equipment connected directly. So, what are we going to do? Well, we're going to put edge. We're going to have edge compute. We're going to have edge compute and edge software. We're going to have edge applications. So we're going to have things that push applications to these edges. These applications are going to be what understands and then secures it. We're probably going to figure out there how not to have to. I mean, we love Ericsson and we love their 5G, but we don't want to pay them all our money. We want to give them just the right amount of money for the data we want to get back, right? I guess that might be AT&T more than you, right? So, but in the end, right, what we needed, edge computing is critical to these solutions, whether it's the data integration challenge we just hit, whether it's the security challenge, and do we trust this stuff being connected when it's national infrastructure? Edge computing is how we're going to make it cost effective, because these pieces of hardware in the field are cheaper in the long run than necessarily sending all that data, the raw video feeds or whatever it is. So, I really don't think many of our use cases that we're starting to see today, connected agriculture, right? The margins on a connected plant can be narrow, right? And small. So how do you do that? Well, you do that
unless it's cannabis.
Fair enough. There are a few industries that
high margin
plants. But in the end, edge is what makes a lot of these things economically viable. Right. And that's why edge is so important. And that's why we have application management. That's why we have edge applications. That's why we have the network security, all being driven around the edge here.
So we talked
So
you talked a lot about kind of legacy and all that, and so obviously what we do is ZEDEDA, we're edge orchestration, security, and management, and um, different because we support not only containers, everyone containers, cloud native, everyone's moving that way, but also virtual machines. Because man, there's a lot of legacy out there, and you can't just say, hey, just rewrite everything and move it over to containers and all these bells and whistles and whatnot. And so I think we're all the name of the game we're saying is you must accommodate current systems. You must mitigate between different models. Trying to drive one single standard to rule the world or one way of doing it is pretty much impossible.
So let me answer your question, because you asked a question about how digital twins are related to the edge. And so I'll just tell you based on my experience. Had to start doing the edge a long time ago. Actually had the slap in the face a long time ago, back when I was at Microsoft, talking to some giant aircraft manufacturer who said, you expect us to send terabytes of data per hour over expensive bandwidth to some distant cloud to munch on data for a while to come back not in milliseconds. And so I was like, oh, I guess we need something here. And so in my background with the edge was, at least my experience with it, it was in the factory floor. We talk about gateways and edge gateways and putting this compute near machines. And so with digital twins, I always think of it. So you talk about you doing edge orchestration, and so let's say I built my core IoT platform. Let's just say, for argument's sake, this big core thing runs in a cloud. Of course, it's multi-cloud. And this place might be the source of my twins, and how I model them might be here, how I might have KPIs and apply analytics, but no doubt about it. And way out here, I've got the device, but I might have some edge thing in between, right? That's near the device. And so in my experience, what we did is we had the notion of the twins might be built here, but we would push twins down to an edge location. So early days of edge, back when the dinosaurs roamed the earth, we talked about, it was like this industrial PC looking thing, right? And that's how you had it connected with serial ports and all kinds of stuff. And so it might be talking to a number of machines locally on the same LAN potentially, right? Or serial or whatever. And so we push twins down to the smaller device along with their own analytics and KPIs, just like we would do back up here. And, and guess what? You didn't need as much compute because you're not doing as much. You're only doing analytics on just a handful of devices, but you're doing it locally. And so you get that power of the twin locally and take care of it there. Obviously, for other scenarios, you may have to go all the way back to the cloud, just depending on the use case. But it was important to have twins move around the system. Just like you may see, I can't speak for Clearblade, but lots of folks, when they do edge orchestration, they may build the analytics in a dashboard in the cloud and then push them down. Edge is hard. Edge is really hard. A lot of people don't realize how hard edge is, because cloud is infinitely easier than edge, because cloud is just this hub and spoke one-to-many thing. And so you do it one time. Edge is, I'm doing it 10,000 times for all these things, and I've got to manage all these deals. And so the word orchestration is huge. A lot of people don't realize about that element. And then telecom somehow jumped on the edge bandwagon a few years ago and said, edge is about 5G somehow. What? Edge is going to live in baseband and base stations, and it's going to be on cell towers, and that's going to be awesome. And we're all in with mech. Good luck, folks. It's hard. It's just a location. Right.
Well, yeah. And I'll add one more thing, because you talked about a bunch, right? The use cases today that a lot of people are doing in industrial, there's HMIs out in the field, right? They can go to their machines today and actually look at state. I've learned that the edge actually has to bring that HMI all the way down, right? I can't rely on going all the way to my cloud to find out what's happening in front of me, right? Even if I don't have augmented reality and I can't look at additional, I've got to be able to host my entire application right there at the edge for us to look at and understand. You're absolutely right. That edge and getting the right pieces and parts and the right amount of hydration, to use that word, about that digital twin that you can have to take just the analytics you need. It's a synchronization and a real kind of deployment challenge.
synchronizing twins.
Synchronization, the data synchronization is a lovely, lovely problem.
It is. It
A
is. for
question
sure.
from Vishnu is, do we expect the big OEMs to be able to push their models on other, on everybody, or are they going to have to maintain them? And I think it's very related to what we've been talking about, is the odds of unless you're really, really large and vertically integrated, the odds of that happening are pretty slim.
There have been standards bodies. I mean, the consortiums, the Industry 4.0, right? And those people did try to make us a standard model. But by the time they come around with a standard model, it's like looking 12 years back in time and saying, well, this is not how I do this now. So I believe we're going to get a lot of great models from a lot of great vendors, but I don't think we're going to be able to get one. We got to be,
Still an integration project in the end.
It is, because we're living in a winner take all world in this space. In spite of lots of people saying we should work together and build and stuff like that, the biggest players are like, no, we're here to win the whole thing at the expense of all the rest of you. And that's just what it is. We can all see it. And so we're going to have to just deal with it.
Yeah. So here's a question. So from Steve, this is getting into advanced class. Steve with Mog Nation is asking, how once you get past POC party of few, and you're scaling something, you've done an integration project or whatever, how do you identify problems in the whole process, through the whole data life cycle, and fix scaling issues? How do you go about that?
Through the clever use of logging. You know what? A lot of this stuff is not IoT or whatever specific to this. This is just software 101, right? And computing. And so all the skills that we've had over the years building giant scale systems, some of us old timers actually have to know how to build that stuff. Obviously with the cloud today, you don't have to have those skills anymore. You just twist some knobs and scalability happens, right? But some of us actually had to build giant globally scalable systems before you had the cloud. And there's a lot of techniques. Like I said, I learned the most about building scalable systems and building financial trading systems, and so you have to be monitoring, logging every aspect of the system as things are flowing through to absolutely find those bottlenecks. Because Steve is right. Lots of people do POCs and they're like, okay, it's good. We got it. It works. And then at scale, it falls down, right? And so it's the same reason why we do IoT. You've got to measure.
Yeah, I mean, I think scalability is what proves why people are still here after 10 years, right? I mean, there's a reason why we're all still talking this, because you're going to have to scale in order for us all to have revenue. We have to have customers that are scaling. That's what keeps us in the game. So we invest a ton in it. Again, I won't go into where we focus on it, but we invest a ton in it because that's ultimately how we're all going to be successful, and our customers are going to be successful. And I think that performance, we talk about the cloud side or that server side, that performance, I think, matters even more on these edge gateways, right? Because, the facts are an ARM chip or a MIPS chip or an ARM chip from 10 years ago that has a 30-year guaranteed life is far more cost advantageous, right? And that pushes performance on these applications. To your point, not everything gets to be a big container, right? A 2 gig container, right? Now we're talking about we need to use 30 meg or something like that. So it's incredibly important. And certainly, your POC probably should say, I need to prove some scalability and some long-term metrics on how this is viable for what we're doing.
Yep.
The more compute you can do on the device or near the device, the less you can have to do in the cloud. And then just like Aaron says, push that compute as far down as you can, and that helps you with scalability.
Yeah, and we see all the time, people that, from our standpoint, from an orchestration standpoint, like, oh, I can do all that. Like that's easy. And you're in POC party of few and, doing scripting and all that. And then all of a sudden you're like, oh yeah, this is hard. The types of stuff I think we all do. People start to realize the challenges once you get out of the lab. So we're at time. There's a couple questions. Leah had mentioned that we'll get back to you guys, through email. I guess this is my Closing bell. I think it was a great match. Leonard's disappointed because we didn't throw chairs and yell.
Ah,
Next time, Leonard, next time.
I did like that someone picked up that there's an audience member back here with a little ZEDEDA sign. That's my
yeah.
my little Where's Waldo. But
I love it.
so we're I appreciate you guys for joining, and appreciate everyone for being on the line, and really appreciating the engagement. We're going to be doing more of these, as part of our Transform Digest series. We're going to do one on Edge AI in a matter of weeks, so stay tuned on that. And Aaron and Rob, again, I really appreciate you guys joining. We had a lot of fun this week online talk, but yeah, it was great. So with that, thanks all, and we'll see you next time.
Thanks, everybody.
Thanks everybody.